Our next speaker is Stefanie Harvey. Stefanie is currently R&D Program Manager at SEMI, leading sponsored programs for flexible hybrid electronics and wearable sensors. A material scientist with 24 years of Silicon Valley product development and manufacturing experience. She led the team that built the world's first dedicated carbon nanotube wire and cable production facility. Please help me welcome Stefanie Harvey.
It's really great to be here. I'm also very nervous. No kids, just being among faculty that I've respected for so long and seeing my peers. Now, Joe, great to see you. This guy got me through polymer physics, polymer class. I was a physics undergrad, and I took no organic chemistry before I came to the University of Minnesota. So that made that polymer, Frank Bates polymer class super fun. As mentioned, I've worked in Silicon Valley for 24 years, primarily doing product development, a bunch of different roles in electronic devices and also consumer industry. Today I'm going to have a lot of slides. I'm going to go through them quickly, but I'm going to talk about wearables and consumer markets and why it didn't really take off. And then I'm going to talk about wearables as part of the Internet of Things. And how many people are tired of hearing about the Internet of Things? Let me see some hands. Okay, great. I will join you in that discussion. And then we're going to hopefully slow down a little bit and get to the meat of the talk. I apologize for all the exposition, but I've noticed engineers need to know why we do something. Otherwise, it's very hard to make them work. We'll talk about wearables as part of smart medical technology, and then what I do at SEMI, which is I take your tax dollars and I give them away to universities, startups, entrepreneurs, even large companies like Lockheed and 3M to do research for both military and commercial applications. So what is a wearable? So everyone in here is wearing something, and I appreciate that. Thank you very much for getting dressed. We're going to define it as a device that has an electronic component that augments senses or capabilities, and it's worn on an individual. So in theory, I could take my iPhone and slap some duct tape on it and put it on my arm, which I think a lot of us joggers did about 10 years ago, and that could ostensibly be a wearable, but we're looking for more performance than that. Wearables have existed for a long time. I won't go through those pictures, but I do want to point out that a lot of the technology that the people of the Fitbits and other places in the world came up with actually have existed for a long time. And the great goal of 10,000 steps was chosen by a Japanese electronics company. What's very interesting to me, especially as I've approached a certain milestone, I turned 50 this year, is the electric hearing aid was invented in 1888, and the wearable hearing aid patent came out in 1938. So we don't see a lot of form factor change from the earliest commercialization. So we have a World War I aviator watch here, and we have a Samsung smartwatch. And here's that early hearing aid. These are the batteries, kind of fuel cell-like right there. This is the controller. And this is the hearing aid that my mother purchased last year. And it's got a lot of software in there that enables her to change the profile of the microphones for television versus being in a restaurant or versus spending time with me when she turns the batteries off, has been my experience. So why does it look the same? Well, one is human form factors have not changed. Though when I presented this presentation to my partner, she mentioned that I guess some people are getting bone spurs from looking at their phone too much. I mean, I don't think that's going into our gene line yet. Two main things: silicon microelectronics are rectilinear; they've always been square. Some of us, tall and thin people, are somewhat rectilinear. I tend to represent the more spherical people on the planet. They don't fit me as well. Fashion designers and electronics designers are now beginning to collaborate. When I worked at Fitbit, I worked next to the color, material, and finish group. The people there, I was working on smart fabric materials, so consider a smart shirt. One use application would be for infants, for sudden infant death syndrome. You get a profile of your baby's respiration throughout the night. Another application is for athletes. Other application could be for military to have active cooling. Anyway, those are the kinds of things we were working on. And the designers had a totally different viewpoint than I did, and we had totally different languages. And one example is I said, you know, we have to put this through the dryer at 40 degrees C for 50 cycles. And there she was in her couture, and she looked at me in my jeans and t-shirt and said, who puts clothing in the dryer? And I was like, me? And I was like, well, what do you do? She goes, you put them on a drying rack. And I was like, how do you dry your sheets? Anyway, but we got to learn to speak to each other. From a science point of view, what's really technically challenging is the soft to hard material termination. We enjoy soft things against our person. Silicon electronics currently is still very stiff and hard. Flexible component miniaturization. We have a lot of flexible electronics, but they're not small enough to do for easy packaging. And then also device reliability. I'll talk about that in a second. And then cost. If it's a consumer product, people don't want to pay. So here's a case study in fitness trackers, and I won't go through all the details here, but Jawbone was really the first leader. They did Bluetooth headsets and Bluetooth audio players, and they got very lucky. In California, the hands-free cell phone law happened, and they went from having a user base of not too many people to having 30 million people who did not want to get a ticket. So at one point, they had almost $1 billion in VC funding and a $3 billion valuation. And their differentiator was design. It was kind of pretty. I worked for these guys. And what happened is Jawbone had a materials issue. They had a nickel contamination issue. And about 10 to 20% of the population is allergic to nickel. So they had to recall their product, and in that time, Fitbit stepped in. With a lot of schadenfreude, only to have their own nickel contamination issue 2 years later. Their maximum market capitalization was $11 billion. Now it's $1.2 billion. That could have changed. I haven't checked the stock market today. Their differentiator was socialization. But the winners really are Garmin, Apple, and Samsung. And Garmin wins because they have a well-defined user base and they leverage the GPS integration, which is their core competency. Apple and Samsung win because they have established ecosystems. For those of us in the Apple ecosystem, we love our walled-in garden. Thank you very much. They have ease of use, phone integration, brand awareness, quality, and reliability. I can't give you exact numbers, but for these two companies, roughly 30 to 40% of devices failed in the first 6 months. And that's a really bad way to build a business. So what do we need? We need a market, our capitalistic society, let's focus on that. And we also need to realize that the machines that were making these devices are retooled from cell phones. And the components and the materials that you use to make a cell phone may not necessarily make the best wearable. So we have opportunities, form factors, patches. People are familiar with patches, from Band-Aids to cigarette, nicotine patches, pain patches. No electronic interface required. So the user simply can place the patch and go on with their business. Textiles. All of us are clothed. There is existing automation for textiles worldwide. The challenge here is how do you do the soft, meaning the textile, and hard, meaning the electronics termination tools. How do you scale those tools up? And how do you really make that connector? You don't want a battery pack you have to disconnect before you throw the clothes in the washer and the dryer. And you certainly don't want to throw the battery pack in the dryer. Then the other question is power. I happen to be wearing a Fitbit. I, drank my own bath water, whatever you want to call it. But these have to be charged frequently. The Apple Watch has to be charged every night if you use it. So now we have to find extreme low power devices, especially in IoT and ubiquitous computing. We want sensing and communicating on demand, which requires good algorithm and good circuit design. And ultimately, if you could do energy harvesting, that would, even at small amounts of passive gain, that would extend the wearability and use of a device. So let's take a look at the Gartner hype cycles. How many people here are familiar with Gartner hype cycle? Okay, I know naturally probably defined it, but so the idea of the Gartner hype cycle, especially for our students here, is a product becomes popular. There's a trigger, an innovation trigger, and then there is this peak of inflated expectations where it's at the top of the hype, and then people get disenchanted, and then slowly the product gets adopted by the community. And adoption is about 20 to 30% of the total available market using the device. And in 2015, wearables were in the peak of inflated expectations. Quantum computing and brain-computer interfaces were being triggered. People were getting tired of cryptocurrency, but they were still making money. And 3D printing was already on the slope of enlightenment, enterprise 3D printing, which we just saw in our previous talk. If we go to 2018, wearables are no longer featured. Wonk wonk, right? Very sad. Carbon nanotubes, carbon-60, which was what I looked at when I first joined.
You move your mic up just a tad.
Oh, okay, thank you.
It's kind of falling down.
We're sliding.
There you go.
Is that better? Okay, let me grab some water too. Excuse me a moment. Having my Marco Rubio moment here. Come on, someone had to do politics. Why not me? All right. So 2018, it's all gone away, and what we see is that everyone's pretty disillusioned with wearables at that point. But it's really not as bad as it seems. So what I've done is I've taken many of the products that are available and put them in this little table and said, where are they in the hype cycle? And bolded the ones which I think will be winners. Skin bio patches, and we're starting to see some of that out there. Smart footwear. I was able, when I worked at Flextronics, to work on the Nike shoe, the self-lacing shoe. There's a lot of real estate in a shoe. And so you can put in batteries and electronics, and it's really fun. Whoever figures this out is going to be the next richest person in the world, non-invasive glucose monitoring. Diabetes and diabetes management costs about 30% of the U.S. Health economy. And so there is great gains to be made to be able to control the disease earlier or prevent the disease. At the peak right now, mobile EKG devices, so Apple Watch 4 has the little button where you close the circuit and it does a simple EKG. Electromyography wearables are becoming popular. Most people have encountered them as TENS units, so you might have seen it back in a sports rehab. They use that to stimulate muscles. Bruce Lee used to build his muscles that way between movie shoots, things like that. Gesture control devices, also there. These are coming out of the R&D. This utilizes existing technology. And then on this side, pretty much we're in adoption. Connected personal hearing devices, we call it Alexa. Or we say, okay, Google, or hey, Siri. Oh, it's not on. I was hoping she'd answer me. So in January of this year, I went to CES, and here's a small selection of wearables, and you can kind of see what they're trying to do on consumer. So With Things, which was acquired by Samsung, has the ECG, or EKG, alternately if you want to do it German or English. Willow 2 has a breast pump, and this is really fun to present to undergraduates when there's 80% guys in the room. And the reason why, and this is a problem we had at Fitbit. At Fitbit, the average age, when I joined, I was 46 years old at Fitbit, the average age was 26. So I was the age of their mom. And I liked that. I mentored them. But the thing they didn't realize is the average person buying the Fitbit looked more like me than the people building it. And so they were focused on sports. You're going to use a Garmin for that. You know, I want to walk around the mall and get my 10,000 steps. That's a little weight to lose there. Something I'm very excited about, Exosystems, Exo Rehab was showing their rehab. This is for people who've had ACL surgery or other knee issues. They, of course, show it on someone who looks like she has not had any issues. It's nice to have. You've got the mixed reality glasses, the N-Rail. And this is, Google Glass was a big thing. I used it at my labs. I was at Tyco Electronics at the time, former Raychem, doing carbon nanotube work. And we would record our experiments with our Google Glass and be able to create documentation and learn things. It was very unpopular, and people would get punched out in bars, and there was disparaging names like glass holes given to people who wore them. And you can Google that, that's real. The other area where you find a lot of wearables where they start, and this is true also in materials development in general, is in toys and in sports. So these are two little devices. This is a toy designed for children or middle-aged children like myself, where you want to drum, and you just wear these 2 rings, and all of a sudden you're a beat master. And then La Roche-Posay, who owns L'Oreal, had come out with a UV patch. You could go out and sunbathe, and it would tell you time to put on some sunscreen or be prepared to age quickly. By which they will sell you a different product. And this is the Skin Track pH. And the idea is you wear it, and then it recommends what type of lotions or potions you should buy for them. And actually, some of the most intelligent wearables, augmented reality, and other technologies like that I saw at CES were in what was called smart retail. Okay, I gotta watch time. So okay, wearables are things. And I'm gonna say wearables are just a part of IoT. And that means we have an ecosystem that includes devices, communication, some software mystery to me, and data analysis. And IoT got sold as the next great thing. It does have a pretty good installed base, but people didn't make the money they thought they were going to make. And I'll explain why in a second, or at least my opinion as to why in a second. So if quickly just want to say, wearables are a subset. We see semiconductors dominate IoT, flexible electronics, what I'm interested in. The CAGR estimates vary widely. Some marketing teams will say it's 70% a year, other 2% a year. I've seen it roughly 13% with a very large standard deviation among firms. And health and wellness leads growth for flexible electronics. My comment is don't position wearables as a pure play. Fitbit survives because Apple Watch does not have sleep capability, because you have to charge that Apple Watch. People who wear a Fitbit are more obsessed about their sleep than their steps. Anyone from Apple here? I'd like a little kickback when you do that. So this is something I've been struggling with as an engineering manager for years. I love hardware. I love to build things. Actually, I like to break things more than I like to build them. But you have to build them first to break. So the idea is you have a transducer and you have some power. And so you have a signal, some either electrical, mechanical, thermal, radiant, whatever, physics happens. And then that has to be powered some way. So you've got your batteries, your supercapacities, your fuel cells, energy harvesting someday, I hope. And you get that signal out primarily wirelessly. People don't want to be tethered as much as they used to. And then you have some signal cleanup and analytics. And a lot of this is being able to take out noise, take out ambient conditions. For military applications, you have to consider you might be in a hypobaric environment or a very high vibration environment. What does that noise look like? And then the outcome is what really differentiates the product. And so the first 3 modules are generic to any sensor system, in my opinion. And so when I was working at a consumer manufacturing company, I said, all we make is a black box. And the differentiator is in what you do with that signal and how you sell that data or how you make decisions based on that data. And so we are just a small commoditized part of that chain. We're not the value add, and we're not going to make a lot of money. So now let me switch gears slightly. I work at SEMI-FlexTech. SEMI is a trade association with over 2,500 member companies and over 1.2 million members. We represent the electronics supply chain. We're turning 50 next year, so it's a little younger than I am. And it started as semiconductor equipment and materials, and now it's gone to include, via acquisition, design organizations, and then device makers, and then application makers. And we've broken up the ecosystem into 5 verticals. All those verticals have the word smart in front of it because we also acquired a MEMS and sensors group. And so they got to put that on the marketing. But the idea is we've got transportation, data, medtech, manufacturing, which is really a subset of IoT. It's industrial IoT. And then IoT, which we used to call consumer electronics. So smart transportation, autonomous vehicles really take the head of that. We have some market projections here. This is in about 67 billion. Smart data, we've got AI or machine learning, blockchain, 5G. Up and coming, really exciting stuff. We're also going to be funding some of this is quantum computing. I think that's really possibly the next big thing post ICE, the integrated circuit. MedTech, 31 billion, smart manufacturing, just under $1 trillion, and then IoT supposedly going up to 11 trillion. Don't know if I really believe that. The winners in smart manufacturing are Industry 4.0, which came out of Germany, Factory 4.0. And then the winners, I think, in IoT truly are smart city. Smart home really hasn't taken off. And then you've got the voice assistant, wearables, and an area I think totally loans itself to IoT is agriculture. And there's some very interesting companies doing work there. So we are focused on health and wellness, and we're interested in a couple of different areas. One is cognitive function. It is very important for the Air Force for their pilots to maintain cognitive function. They don't have a way right now to tell when a pilot has fallen asleep other than a camera that notices their eyes are closed. And if they met my dad, they would realize you can fall asleep with your eyes open. Telemedicine is important. Right before I flew out to Minnesota, I actually had a video visit with a nurse practitioner. Treatment response is key for the military right now. If we take the warfighter out of the field and let's say somewhere in the Middle East, get them to Germany for final hospitalization, that usually takes 8 trips. There is no electronic tracking. It's all on paper, and it's done by handoff. And it can take 48 to 72 hours to go from the field to in-house care. So the other thing we're also interested in is performance monitoring. You have improved health and fitness, athletic performance is a given, but you can also do things like track the progress of neurological diseases. And this is key in aging in place. It doesn't have to be a wearable. You can have a LiDAR system sitting on the nightstand, and it informs you your parent has gotten up that day, or they've opened the refrigerator door. And you don't have to buy a Nest Cam and spy on your family, which is how I did it with my mom when she was living independently. And the whole model has changed, and I really hope that this is not only true of what we're funding, but for all of us. So in the 20th century, we had a bottleneck, and the bottleneck was the physician. So labs and vitals, diagnostics, pharma, got to the patient. Now we have a community. We want to be outcome-based, decentralized, personalized, but more importantly, all the providers are connected, and then you have this new person who plays a big role in your healthcare, the data scientist. Oops, let me go back. Let's check time. Ooh, running close. All right. So key biometric data and formats. Essentially, most of the diseases that affect human beings can easily be measured on the person. Different locations of the body. The wrist is actually a terrible place to do biometric measurements, by the way. So Fitbit and Jawbone and Apple have raised the bar a little too high. This is taken from some work at GE where they did a review, but you can see things are worn on the person, worn on clothing, can be implanted, and that's for serious disease management, can be ingested. There is Proteus in Hayward and Redwood City, California. Hepatitis C is a big problem in the homeless community. 20 pills, and you're done with hepatitis C now, but you have to take them. And they have, essentially what they do is the pill has a detector, you wear a patch, and it confirms that you are compliant to taking the medication. Those pills are over $1,000 a piece. So they want to make sure it's taken. Joe Wang's group at UCSD has come up with a bunch of great printed electronics tattoos, they're called. They're like water tattoos, like when little kids tattoo themselves at the state fair. And they can track glucose, they can track alcohol content, they can track hydration, a lot of different things. And then MC10 has something called the BioPack, where you can do a large set of metrics, and that comes out of John Rogers' group, originally University of Illinois and now at Northwestern. Lots of startups. These startups are focused on clinical efficiency, using glasses to do for a doctor to take notes, so you get video and you get audio in the glasses, for example. Or a WearPoint has ID, so infants won't get mixed up, being taken home, and then patients are in the right surgical theater getting the right procedure. Sleep monitoring is a big deal. Infant monitoring is healthy. What else do we have? Neurotechnology is really coming up, and I'm very interested in that and looking to fund that as well. And of course, since this slide was made, several of these companies have gone out of business. I didn't make the slide this morning, though. So how do we accelerate technology development? Public-private partnerships. It's hard to start an industry from zero. And so our organization began as a display consortium. We relaunched as the FlexTech Alliance, and then we added the Nanobiomanufacturing Consortium. That's the first phase of the NBMC. Now we are at the Nanobiomaterials Consortium, our second phase. Overall, we've done $400 million of federal investment and industry match. And so the model is fairly simple. We have industrial partners that have their own objectives and market drivers. Oops, pardon me, let me go back. And we have the U.S. government mission. And in our case, that's the Army Research Lab and the Air Force Research Lab. And so we choose a governing council. We have a go-to-market advisory group, people who understand business and make sure we are dual use. And then we have a technology council. And my day-to-day job is running this. I scout technologies, I create the technology landscape, and I work with staff-level engineers on identifying and managing R&D projects. So for FlexTech, we're looking at CMOS integration, power, and sensing. For NBMC, it's human performance and human augmentation on wearable devices. And we had a spin-out funded by the Obama administration called NextFlex. And that's actually a pilot line that's in San Jose, California, where you can produce these materials. So the way I already talked about this, but here's an example. We assemble our investment partners. We identify needs and challenges. Right here, we've got a little baby in the ICU, and we've got a pilot. Both of them are in hyperbaric environments. They need more oxygen. We assess the technology landscape, usually through meetings where we get the community together. We issue requests for proposals, and then we fund with a typical 50% cost share, which could be cash, equipment, time, labor, things like that. And frequently we'll have a theme. And in this case, we had a power initiative example where we worked with a series of companies to advance power. Finally, something technical. What we want to do is we want to merge printed electronics with traditional high-performance semiconductors. You can't print a really great logic chip right now. But we want to be able to take it and add it to things that you can't print. And it has to be stretchable and conformable. So very quickly, 3 examples of our successes. One is from GE. This is a flexible, non-invasive wearable for hydration. They have 2 ways of measuring it through sodium and calcium concentration in sweat, so they had to do a lot of microfluidics design. This was their first prototype. They also had an RF impedance patch to do tomography and spectroscopy to see subcutaneous hydration. The data is pretty loud. You have to do a lot of processing and conditioning of the data. And I just want to point out that scientists are not all just nerds behind the desk. This is the PI. This is the mechanical engineer, and this is the microfluidics guy. So, go us. All right. For flexible hybrid performance ICs, we're working with American Semiconductor, and what they do is they thin CMOS to about 20 or 30 microns so that it has a little bit of bend. We use pick-and-place robotics and do 3D additive interconnection, and then that goes into roll-to-roll manufacturing. What you see right there rolled up is an Arduino chip. The thing we're very proud of is some work we've done with ITN, Energy, and Lucentech, going from a button battery format to something that is about the size of the first joint of your thumb, 250 microns thick, and it's self-recharging because we put some PB on the back. That's actually built on a ceramic substrate, a YSC, and we now are funding, again, the same players with the University of Rhode Island. They're taking this solid-state battery stack, adding some control chips, putting on, making that an integrated power module, and now we're adding an explosives trace detection module. And so that has a military application. The consumer use we're looking at is cannabis detection. I live in a state where you are free to enjoy cannabis at will, And there's a joke. How do you tell if someone's driving stoned? They wait at the stop sign until it turns green. So these are ways that the police can do that. Okay, so we do a technology roadmap, and we look at the market drivers, and these really should be called technology drivers. We go from technology readiness level 3 to 6, and then we push that on to our manufacturing. I'll skip this slide. We've had 2 requests for proposals so far this year. 2 areas of interest are soft robotics and biometric security. Who are you and how do I know who you say you are? And for the Air Force Research Lab, we're very much interested in wearable cuffless blood pressure monitoring and then human biochemistry monitoring, something that can operate for 24 to 72 hours without a battery recharge. And then I'm going to finish. Wearables do not yet have sufficient consumer market pull. Medical technology, I think, is the leading pull, though some people argue auto is. The risk, time to adoption, and cost are sufficiently high to warrant public-private partnerships. And the dual-use application and match funding ensures that we have good stewardship and that we have relevant technology development. Mary Meeker is now at Bond. She prints an internet article every year. She submitted her slides 2 weeks ago, and this is wearable users in the United States. It's 17% of the population, and we're getting close to that golden 20 to 30% adoption needed to be on the plateau of productivity. Thank you.